The following is a demonstration of a method for mapping argument, using data visualization to identify communities of belief in datasets of tens or hundreds of thousands of Twitter posts on a given topic. The process is really a jumping off point for analysis. It prepares the dataset for easy navigation and drawing insights. My research interest in pursuing this approach is in contested and disputed narratives. Platforms such as Twitter are sites for their construction and dissemination. In visualizations, communities advancing or defending competing narratives occupy neighboring territories in the form of clusters of linked nodes, each representing, in a discourse on one event or subject, different framing, varied explanations, definitions, assumptions, and judgments. The first step in this process is devising a search. To scrape data from Twitter, I use a script in the programming language R, but to test search terms first, I use Twitter's regular search function, partly as a self-imposed ethical constraint. All sorts of data can be had from Twitter, but everything I collect comes from a search based on content of tweets, a search anyone can do from the main page. Sometimes a search is based on a single term, but more often searching for tweets on a topic, the game is to capture as many relevant posts as possible while excluding irrelevant ones. And tweets on a subject don't all conveniently contain a hashtag or a single key term. The search interface has a limit of 500 characters. Not uncommon that I use them all, search strings filled with synonyms and Boolean operators. Searches also go back in time at most 9 or 10 days and can capture at maximum of 18,000 tweets every 15 minutes, limits that have shaped my data collection. I run a search while an issue is hot to capture a slice of it then and there. If it's a topic I'm looking at over a longer time, I run searches at intervals for a longitudinal picture. The illustrative example I'm using here is argument about the long-dead British explorer James Cook. Dispute that divides people along political fault lines because opinions on Cook attach to origin stories of the post-colonial Australian nation. A nation with a short history of progress and development, or one of dispossession and genocide. In the context of a pandemic and the 250th anniversary of Cook's first footfall on the continent, a public official, health officer for the state of Victoria, was widely condemned and defended by others for likening one historical event, the onset of COVID-19, to the other, the destruction and disaster that began with Cook's arrival and claiming Australia for the British Empire. My search begins with the official's Twitter handle. She's since deleted not only the tweet but her Twitter account altogether. The most prominent response calling for her to be sacked or resign was from a Victorian Liberal politician. I include his Twitter handle too. Then I broaden the search to include other tweets about the comment and about Cook over a period of about 48 hours. Of interest was the fact that this one tweet from Annelies van Diemen dominated all talk about Cook and the invasion of Australia at this time. Cook's a controversial figure today, and many cutting tweets had been posted. It's a polarizing anniversary, but only this one, from a woman in a relatively prominent public role, had been picked up by Cook's defenders as an affront worthy of censure and punishment. Once the search is ready, I run a short script in R to scrape the tweets. The data is returned in a format with 90 fields for each post, share, or reply. I actively do not want all of this data because some of it's of the sort that connects the content of posts with the author behind the account. This research, though, is focused on semiotics. I treat an account as a corpus of posts, a collection of content. I'm not interested in identifying authors, so part of processing the data for visualization is deleting columns related to location and so on. I ran a script I wrote of about 2,000 lines of very clumsy, inelegant code. I have almost no prior experience in coding, but R is a very easy language to do it in, and I've managed to output the data in some useful and interesting ways. One format allows me to make a semantic map of the terms most often used in the dataset. Another lets me take advantage of an R script for qualitative coding of the dataset. The main aim, though, is to format the data in a few different ways for visualization with the software package Gephi. For this purpose, I'm turning a table of data into pairs of files that are essentially lists, one of the nodes in the dataset and the other of relations or edges. All of the visualizations I'm creating are complex pictures of networks built up from a very simple basic structure. Suppose one account posts a tweet, there's a node. Another account replies to the tweet. Now there's a second node and one relation, because the second tweet is a response to the first. A third account shares or retweets the original post, so another node and another relation. If this account shares the reply as well, there's a relation between these two nodes. There's a few other things going on. For example, the more relations a node has, the larger it becomes, representing its prominence. Also, I'll often use colors to show the kind of relation it is, a reply, a retweet, etc. This is the basis for the network. It's a scheme like this, writ large. So what Gephi wants is a list of nodes and a list of relations. I import both files, then I tick this box to say that the nodes list is from the same dataset. Once these are imported, there's already a visualization. Each node and relation is mapped in this window, but there's no spacing yet. Gephi has several different algorithms for spatial manipulation of the dataset. I generally use the native algorithm Force Atlas 2. There's a few parameters to set to do with how much the different nodes will repel one another. The most gratifying, I'd say addictive part of this process is starting the algorithm running. When the nodes bouncing around reach some kind of equilibrium, I stop the algorithm. Tweaks to the initial layout bring the map into relief. I resize nodes to make prominent nodes visible. I introduce node labels and resize those. I use the same colors on every map at this point. Yellow for shares or retweets, red for replies, blue for mentions, and purple for a share with a comment. This bird's eye view of all of the talk on a subject facilitates a deep dive into the dataset. It's possible to zoom all the way in and pick out any element of exchanges from the most prominent to the least. Rolling over any node with the cursor shows all relations between that and other nodes. Some insights emerge from the visualization itself, from its pattern of clustering, the predominance of certain colors in some regions, and most obviously the relative prominence of nodes, based on number of relations. The map's made navigable by these features. As expected, the search didn't yield any substantial site of discussion about Cook, other than the one centered on the post by Van Diemen comparing Cook and COVID. Most prominent in this view means most replied to, most retweeted, and most talked about in other posts. The public official is at the center of the network. Her chief detractor, the Victorian opposition politician, is another prominent contributor. Others are contributors with many shares or replies, or the subjects of the discourse people being talked about. The view of the map isn't static. Changing its parameters refocuses on different features of the network. For example, node size can represent the most active contributors, rather than the most replied to or talked about. In another window in Gephi, a snapshot of the current map can be prepared at any time and exported. And the original dataset can be processed and visualized in different ways, in maps with a different emphasis. Another map focuses on the most prominent tweets in the dataset, each with a halo of retweets and replies. The emphasis of the visualization I'm working on now, though, using color to show the type of relation between nodes, is the clustering of similar opinions. The areas where yellow is prevalent are those I identify as communities of belief. In this case, two communities, one defending Cook as an upstanding icon and putting the view that Annelies Van Diemen should be made to resign for a tweet. The other is a community supportive of Van Diemen or of her thesis. Areas with yellow prevalent indicate distinct communities in these maps because these are networks of dissemination. A yellow relation is a share, a retweet. That content's being shared within communities and not between them, hence areas dominated by yellow and other regions with no yellow links. In the gulf between these communities, there's a region of red links, replies, representing a kind of front, and dispute or dialogue across the border. Blue relations between nodes are mentions. The content of a tweet includes a Twitter account's label. So nodes with many blue links are in a strange category. They may have contributed to the discourse or not at all. Their involvement sometimes seems more like that of the characters of evolving narratives than participants. Some are invoked in only one community's narrative, so the node appears there. Others are salient figures one way or another for all communities' narratives. The node representing them is pulled in both directions from both sides of this region of dispute in red. This is a highly abstract way to talk about a Twitter exchange, so I ought to say that if this is your post at the center of a culture war outing like this, the experience can be a tide of replies and messages, including many that may be insulting or threatening. Certainly, the dataset can be taken as either another example of an elliptical clash over the country's contested historical narratives, or as another instance of a woman targeted by a specific community, not only as a subject of discussion and derision, but with an intention of retribution of some kind. By itself, this interpretation of the map is reliant on one assumption, that networks in which dissemination is prevalent correlate with communities. One way to verify the method based on this assumption is just looking more closely at the content of the regions identified as representing communities of belief. A second approach is reliant again on a characteristic of the network, that communities of belief are consistent across diverse issues. It's therefore possible to map communities identified in a visualization on one topic onto a set of nodes in a new visualization on another issue. There's a plugin for Gephi that allows that node colors can be exported from one map and imported into others. I was trying this out, experimenting, and I exported node colors from a map of a discussion that followed John Cleese posting on Twitter that London isn't as English as it used to be. I then imported the node colors onto another map that I was working on at the time about an IPBES report predicting the possible extinction of 1 million species. Two very different issues, but the set of posts advancing a narrative on one issue could be used to accurately locate a community advancing a narrative on the other completely different topic. I'm now using this feature of Twitter communities as a complement to the method just described, as an overlay that cross-references communities against another dataset. But in a sense, it's also the strongest finding from this research overall, the consistency of communities across different topics. For the visualization of this May 2020 dataset of Talk About Cook, I'll use the node colours of communities of belief from a map from May 2019 at the time of the last Australian federal election. Then the proposition is that if the regions of colour picked out by both processes match, the veracity of the method as a means of identifying camps or factions or communities of belief in visualizations of many thousands of posts is enhanced.